not going to be long before AI becomes our masters. They're already smarter than us. So I thought I'll get some practice. Instead of me delivering a talk, I'll let the AI deliver the talk, and I'll just be the instrument to pass that gyan on to you. In this talk, I'm only going to take instructions from ChatGPT. I'm not going to tell it what to do. So let me begin. I'm delivering a talk on finding actor lookalikes using multimodal LLMs. Help me with the agenda. And let me follow this very sincerely. Okay, it says, firstly, remember folks, you can ask questions at any time. Just keep your question under 5 seconds. It's eating into my talk time. And we'll keep it to one question per person in the middle. Towards the end, feel free to ask however many questions you want. Organizers, please just keep the mics rolling. Whoever needs the mic, please pass it along. It says what I should do is begin by how I got started with exploring actor lookalikes. I'm not even going to second guess this. I'm not even going to look at the agenda. I'm going to follow it blindly. Actually, the reason I got, well, first, I'm generally very interested in movies and actors and the whole like. I have for a long time, like many other people, been trying to figure out who should the cast of the Mahabharata be if it were to be taken as a picture or a TV series. You know, I mean, Amir Khan clearly wants to play Krishna, and there's a whole bunch of actors who have their own preferences. I'm also trying to figure out who would be the cast of any of Brandon Sanderson's books if they were created, not as a Bollywood movie, but as a Hollywood movie. And in this, there are a few people that often end up as, you could pick this person, you could pick that person. That apart, I anyway get confused sometimes when I see actors and I say, oh, this is so-and-so, and my dad says, no, that's somebody else. And then we look at the pictures and say, okay, they are probably, they do look alike. So is there a science to this? Can we systematically figure out who looks like what? So that's where I got started with this. But I'm curious, what actor would you like to find a lookalike for? And we'll do a show of hands. Please raise your hand if you want to find the closest lookalike to Ranveer Singh. Okay, 1, 2, 3, okay. Oh, 4 there. Deepika Padukone. Okay, that's about the same number. 4. Shah Rukh Khan. Okay, that's definitely higher. That's about 7 or 8. And Priyanka Chopra. Okay, slightly higher than Shah Rukh Khan. I think there were about 10 people. So fine, Priyanka Chopra is whom we want to go after, followed by Shah Rukh Khan. Time permitting, we'll go down for the others, but that's roughly what we're going to be exploring in this talk. But let's talk about highlighting the quality. See, we know that LLMs have problems, and let's explore what kind of problems LLMs have. So help me with the highlight quality section. I'm sure ChatGPT can give me some gyan. Okay, it's saying spoiler alert, they can be a bit like trying to get a perfect selfie with a potato. I have no idea what that joke means, but it's clearly trying to be funny. Have you tried asking an LLM to guess a random number? It is hopeless. You'll actually find that, well, let's look at this picture that it's picked. This is the distribution of the number that LLMs pick when they are asked to pick a random number. Let's in fact show an interactive number. What we did was asked LLMs to pick random numbers, and for each LLM, log the results. So let's take Claude 3 HiQ, for instance, and let's animate these guesses. Each of these little sparkles is when it's making one guess, and on top you see the counter, and the bottom also you see a counter, and you'll see that 42 is clearly emerging as the winner. In short, when asked to guess a random number, it strongly prefers 42. Most of you know why. For those of you who don't, read Douglas Adams' Hitchhiker's Guide to the Galaxy. Those of you who know, read Douglas Adams' Hitchhiker's Guide to the Galaxy again anyway. It's a good book. Now, the thing is, the temperature makes a difference. When you pick a temperature of 0 in the model, that's basically telling the model, by and large, pick what you're really sure of. Then it pretty much only picks 42, 98%, 0.5% of the time. And 1.5% of the time, it says 47. If you increase the temperature to maybe 0.1, then it says, okay, I will also happen to pick 57. But it's only when you get to a temperature of 1, which is saying, go crazy, pick fairly wide random numbers, when it starts guessing a whole bunch of other numbers. But even then, you'll find that it does not guess any single-digit number. In fact, I made a list of it. The classic kinds of biases that humans have. It rarely picks numbers that are below 10. It very often picks numbers that ends with 7. It rarely repeats digits. These are exactly the kind of biases that a human would have when guessing a random number. Most humans tend to pick 37. Most programmers probably pick 42, so you know what kind of data Claude 3 Haiku has been trained on. And OpenAI makes similar biases. So if you asked, I thought this was supposed to work. If you asked GPT 3.5 to pick a number, you can see at the bottom that it's 47 that's emerging gently and becoming the winner. Gemini has a very different kind of bias. You'll find that it's nudging up 72 a lot, though it does really like 42, it does really like 37. All models like 37, like any human. Now, if this is how well a computer program does when I ask it to guess a random number, how well is it going to recognize the similarity of two humans? So this was problem number 1 for me before embarking on this. The second problem that I had was on calculating the cost. What would it take to run this? So let's actually do that. Calculate the cost of running this. And let's see, how much would the whole operation cost? Well, first, the choice of model at that time, and this was about about a year ago when I started getting this idea. Lava 1.0 had just about been released, so I figured, okay, let's host this on Amazon, and the GPU RAM requirement is reasonably high. I might have needed for the full-fledged Lava 1.0 version A100, and for that, running it for, let's say, a month. It would have taken me a month to get all of the actors' data, run it, figure out that I've messed it up, try again, and then suddenly some urgent project comes up, so I'll just leave the GPU running, go back to that. $2,000 fairly easily for a side project, which would have been a good thing, and I'd have just gone to my co-founder and said, Naveen, why don't we try this out? But just so you know, that's Naveen, by the way. And his reaction is likely to have been, if I said, look, I need $2,000 to find actor lookalikes. Anand, we are in the middle of a fundraise. We need some EBITDA. We can't spend $2,160 and all, and definitely not a few days of your time on finding useless things like actor similarity. Get back to work. He didn't explicitly say this for this because I knew it was his reaction. This is what he generally says. Okay, so what do I do? At least the quality problem I can do something about, but the cost problem I needed to figure out how I can handle it. So realistically, I just had to wait. It turns out that if we look at the pricing of LLMs, things obviously have been improving dramatically. And let's take a quick look at how things have been improving. As of November 2022, the flagship model was GPT 3.5 Turbo. What we have here on the x-axis is the cost of the model on a log scale, and on the y-axis is the LMSys ELO score. The LMSys ELO score, for those of you who may not be familiar with it, is where LMSys has this site. People come in, they ask a question just like they would to ChatGPT, and it gives 2 answers. One from secret model A, one from secret model B, and it asks the user, you pick which one's better, and collates all of those ratings across all of those models, and more than 1.5 million people so far have rated these, or there have been more than 1.5 million ratings so far, so it's got a reasonably robust data set, and that's the y-axis score. The way it's computed is exactly the way the ELO score is computed for chess players or for any pairwise championships. And the x-axis is the cost. This data is almost the same as what you will find from a site like artificialanalysis.ai, except that the x-axis is on a log scale. That's because we think of costs logarithmically, not linearly. So in November 2022, there was pretty much only GPT 3.5 Turbo. And then Claude 1 emerged, GPT 3.5 Turbo's next version emerged, newer version emerged. And you'll notice that these are forming a kind of cost-quality trade-off. More expensive models are better quality, less expensive models are of lower quality. And then there are a few other models. The ones that are highlighted in, I'll show you some of the coloring here. You'll find that some of the models are highlighted in green. That means there is no model that is cheaper and better, which means it's a Pareto optimal model. It makes sense to use these models. Anything that is not in green, there is a model that is both better and cheaper. It makes no sense to use that model. So if I had, let's say, GPT 3.5 Turbo as of December 2023, makes no sense. I could have gone for Quen, which is cheaper and about the same quality, or Command R, which is better and about the same cost. Why would I ever bother using GPT 3.5 Turbo? And this moved and it moved and it moved. And the interesting thing is the emergence of models on the top left. These are models that break the frontier. So the frontier kind of looks like this. DeepSeek Coder V2 Instruct in Feb 2024 broke this a fair bit by saying at 14 cents per million tokens, I will give you a stunning quality result. And then Claude 3 HiQ came up. DeepSeek Coder was a coding model, but Claude 3 HiQ is a regular language model. And that again broke the frontier. For a few months, I was telling everyone on our team, just stick to Claude 3 HiQ for its price alone. Over time, Gemini 1.5 Flash emerged, again breaking that frontier a little bit. And now we have a huge number of models starting June 2024, where on the top is GPT-4o, currently the best rate. Well, almost Gemini is slightly better as of the last few days. But there's also Claude 3.5 Sonnet and Meta 3.1. Meta Llama 3.1405b, which are roughly in the same class. And then there are these cheaper models and much cheaper models. GPT-4o Mini was a breakthrough, on the other hand. What that did was, again, push the frontier further. And the next time we see this, the graph's axis itself would have changed. So that's a huge impact. What that means in practical terms is that what could have, let's say with Claude 3 Opus, cost $30, the exact same thing with potentially slightly less quality would have cost only 25 cents with Claude 3 HiQ. That's the order of magnitude of cost. Now, it usually doesn't help people when we say $30 and 25 cents. Let me tell you what this means in terms of a real budget. If I went to a client and said, for this particular piece of work, you need to pay $10,000, and we can get it done on Claude 3 HiQ, that budget will probably get approved. The exact same thing with Claude 3 Opus would have cost $1.2 million. No chance of getting that through. That's the order of magnitude of difference that we're seeing in terms of models. So both with time and model choice, I can clearly solve this part of the problem. So with that, I figured, let's start. Let's see if we can push the needle even further. And one of the things that I realized that was fairly underutilized is embeddings. Personally, I believe that embeddings are the biggest superpower of LLMs. They are easily the most underused, powerful capability that I've seen. What are embeddings? Well, an embedding converts text into numbers. Not just text, it can even convert pictures into numbers. And these numbers are fairly processable. You can find out if two embeddings are similar to each other very easily. If the numbers are similar, then the meanings behind those pieces of text or images are also fairly similar. So it kind of puts it like a point in space. To give you a sense of how that works, the best way to look at this is using TensorFlow's embedding projector. It uses TensorFlow's embeddings, not LLM embeddings, but the concept is exactly the same. That is a large site, and it does take long, but hopefully I will not be badly delayed on this. Looks like I will be badly delayed on this. Before ChatGPT reminds me, maybe I should remind you, you're welcome at any point to just ask questions. You don't even have to lift your hand or anything. Just if I'm taking instructions from ChatGPT, I may as well take instructions from you as well. At least you're human. So let's say we want to find out what is similar to actors. So each of these little bubbles is a word, and these words are reasonably similar, close enough to actor. So what it's saying is, for instance, actress is fairly close to actor. Where is actress? Okay, we saw singer here. Singer is reasonably close to actor. If I zoom out a little bit, I'm sure I'll find some place where actor, actors, dancer, cricketer. Okay, 3D visualizations are a little too complicated for me. But yeah, here's actress. And the distance between these in this multidimensional space is in fact the closest. Net-net, I can use embeddings in two ways. One, to reduce cost, and let's explore embeddings cost first. Explore embedding cost. But the second is, this gives me something quantitative to lean on to, because I can then say the similarity between, let's say, actor and actress, which no longer seems to appear, but anyway, when it appears, the actor and actress is 0.21. The similarity between something else and something else is quantitative. Whether it's right, whether it's wrong, I don't know. But A, it's repeatable. B, it's comparable. Those are two solid things that I can put my hat on. So let's look at the cost. Now, if we look at the comparison between, let's say, a Claude 3 HiQ and a text embedding 3 small. Claude 3 HiQ is a generative model, ultra cheap. Text embedding 3 small is a fairly good, very inexpensive embedding model. This is the order of magnitude of cost difference. That $10,000 budget for this would come down to, well, I don't know what it is, probably $800 or something. Even lower than the already low budget. But the best part of it is you don't need an API to run these embeddings. I can run it on this laptop, which doesn't have much by way of GPU memory. It's not a gaming laptop or anything. It's just a regular office laptop. And it will work perfectly fine. I can run it on a Colab notebook. And that's because many of these models are available on Hugging Face, BG, Baidu's, Microsoft's E5. These are popular models that I can just run in a Colab notebook and get the result. So now the cost has practically, at least the technology cost has practically fallen to zero. I have a sense of how to manage the quality problem. So I said, okay, now let's start off on actually solving this problem. Now we're getting into the meat of things. Okay, now it's saying time check. I should be 15 minutes into the talk. I'm actually about 18 minutes into the talk, but let's leave out the introduction bit and still continue. I'm still okay. What I'll do is show you what these embeddings look like. Yes, please, there's a question. The cost for embeddings, is it in millions of tokens? Yes, it is. So what that means is it's just a few cents, 2 cents or so, whatever it was, per million tokens. And if you were running it on Colab, it's free. The embeddings, now one of the most beautiful things that has come out in the last couple of months is artifacts on Claude.ai. This dramatically reduces my cost to show demos. So when a talk comes up like this, I don't bother creating a demo beforehand. I just start building it on Claude. For instance, last week, one of the people in our HR team said, Anand, we need some interviewers for database administrators. We don't have any. This is our biggest bottleneck. We're hiring 20 database administrators. How do we solve the problem? Okay, fine. Let's see if we can do this. Create a single page web application that shows 10 questions that will of moderate difficulty. And let's make this without any frameworks, vanilla JS, that will show 10 questions of moderate difficulty that tests a database administrator. Questions are MCQ, they are optional when the user submits. Just show the score on the screen and have it build it. The thing that ChatGPT does is gives you the code. The thing that Claude's artifacts does beyond that is, apart from giving you the code, which it is doing on the right side, and the quality of code, by the way, is extremely good, not just for Anthropic's models. These days, every model is pretty solid. If I ask it to build an app from scratch, it tends to build small apps reasonably well. It struggles a little more when we debug it. So too bad. But the nice thing about it is that it also shows me the output. So I can actually run this, select the next result, select the next, whatever. I'm not even reading the questions, and submit the quiz. And it says I got 3 out of 10 just by random guessing. And the HR team says, "Arey, great. Can I just give it to the candidate?" I said, "Sure. You can click on publish, copy the link, and send it over to them." Ooh, that was not copying the link. Copy the link, and now send it over to them during the face-to-face interview. So the HR team can run a database administrator interview. I said, wow, what else can we do? And the answer is anything on the front end. So since I want to show you what embeddings are, let me build you an app that shows what the embeddings look like. So let's do that. In fact, it's given me a prompt that I could use here. Let me open a local version of this particular app. The reason I'm using a local version of what Claude provides is Claude has a restriction. I cannot fetch APIs from elsewhere. So what I did, because I got this idea at 5:30 or 6 this morning and I couldn't sleep, was I told Claude, look, you've got this application, right? Build me an application exactly like that. And I described it in detail. Between 5:30 and 6, it built me this application. And I hosted it on my website. Now, I can ask my application to create a vanilla JS single-page web app using only CDN libraries, which shows a form with an input for phrase. When I submit, fetch a course-enabled API as follows. And the API is basically from my site /OpenAI v1 embeddings. What this does is takes the request, sends it to OpenAI, gets the request, sends it back. Nothing that is different. Only changes, I don't have to send the OpenAI API key every time. And the structure is send it as JSON, send a model, which is text embedding small, and the input is whatever phrase I enter. Now I'm going to use Llama 3, let's use Llama 3, an even older model, to create this application, which generated the code, finished showing the application. So now I have an application that's running. If I take a phrase like, I don't know, let's say Priyanka, wasn't it? Priyanka Chopra. And submit. It fails. And this is the kind of danger that we have when we run applications live. HTTP 400 is a bad request. This is why you shouldn't build applications at 5:30. Okay, that worked. So this is what the embeddings actually look like. When you send a request for Priyanka Chopra, it says, I'm going to give you an object list, blah, 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 which contains a number 0.02, 0.015 negative, some numbers, a whole series of numbers, probably between -1 and +1. And that's what characterizes Priyanka Chopra, 1,500 of these numbers. Okay, great. This doesn't look very nice, though. I can't quite follow this. Fetch this course-enabled API. From the response, take the data of 0.embedding, show data, the JSON responses, data of 0.embedding, singular, plural, embedding, yeah, values as fixed with, as a 3 decimal list in a fixed width font. And let's see how well it does on that. Blah, blah, blah. Okay, Priyanka again. And yeah, okay, slightly better, but this doesn't look nice. Let's see, a series of Unicode filled circles. The transparency is based on the value scaled from min to max. And that might give me a kind of pictorial representation of Priyanka Chopra, almost like a, okay, yeah, not one below the other, as a, not one below the other, but inline. And create that. Once again, Priyanka Chopra. This is the maximum number of times I've mentioned Priyanka Chopra in any talk. Okay, so that's kind of a pictorial representation of Priyanka Chopra, if you will. All right, good. So we have a sense of embeddings, and the thing about these is that if I have two of these images that are similar, then, or these numbers which are similar, then it also means that the underlying pictures are similar. Now, how can we use that? What's next? Did I miss anything? Did it give me any other instructions? No? Okay. Right, so let's dive into the next part, which is how can I cluster using embeddings. Now, see, if I have numbers and I have the similarity between numbers, I can start applying all of the standard statistical techniques that are there for that. So it allows me, therefore, to calculate the similarity of any two things that can be embedded. So let's do this. Let's take a movie catchphrase data set. This is, okay, can I have this locally, I'm sure? Yeah. This data set, which is on GitHub, by the way, all of this is on GitHub, and I'll share the link with you, has about 150 popular quotes from movies, such as, yeah, Beetlejuice, 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 or what is this one? Yeah, I love the smell of napalm in the morning, Star Trek's Khan. All of these are there. Now, which of these are similar? Can we figure that out not by using generations, but purely by using embeddings? Let's give that a shot. What we'll do is take ChatGPT's recommendation, and it says we should be able to create something like this, where each of these little dots is a movie quote, and they're connected if they're similar enough with each other, and we can figure out the strength of the connection dynamically. And for that, there is a Colab notebook that we can walk through. Let's do this. What we'll do in this Colab notebook is take this movie quotes data set. We'll begin by downloading this particular data set. It's exactly the same CSV that we saw a few seconds ago. Let's download that. And then we will set up a few basic things. Firstly, we'll import my OpenAI API key from the secrets. The file name is catchphrases. The column that we want to process is the catchphrase column. We are going to create 25 subtopics, and then we are going to group them further into 5 topics. What does that mean? See, we can cluster them, and then we can give names to these clusters, saying all of these are, let's say, James Bond quotes, all of these are science fiction quotes, whatever. And then this, rather than creating a bunch of categories from scratch, we can create very small categories and then abstract them out into a hierarchy, which will make it easier to navigate. So we'll start by creating 25 topics, and then square root of that, which is 5. So 5 high-level topics. And then a bunch of other parameters that we can ignore. I just want to mention a couple of things. To name stuff, we are going to be using GPT-4o Mini, but that is only to find out the names of the clusters. Otherwise, we are only going to be using embeddings, and the cost of this is practically 0. Install a bunch of libraries, but the bulk of the code is happening here in the cluster function. What we're doing is first setting up a bisecting k-means model. What is that and why are we doing it? K-means is a model that takes a bunch of numbers and then figures out which of those numbers are close to each other, and then says, oh, all of these are close, cluster 1, all of these are close, cluster 2, etc. Bisecting k-means does that slightly better, in that k-means just blindly comes and says, okay, let me randomly pick a number and see what's close, let me randomly pick another number, what's close. Bisecting k-means kind of takes a look at the data and says, oh, okay, I kind of see a cluster here, let's start with that. I kind of see a cluster here, let's start with that. And then, second step, we actually get those numbers. These numbers we get using LangChain. Why LangChain? Because when I wrote the code, LangChain was pretty popular. Remember that a significant chunk of this code is actually written by LLMs, where I asked it to look at the documentation from somewhere and write it. So it said LangChain works. The only contribution that I made to it is because in this particular talk, I don't want to have things run slowly and take their own time. I added a cached back embedding. This, incidentally, is also a huge cost lever. At Granular and Strive, we find that at least during the experimentation stages when people are building applications, roughly 60% of your cost can be reduced by caching. In production, in bulk, it may reduce to 10%, but even 10% is solid. But somewhere between 10 to 60% is the kind of saving that you have just by caching. So cache everything, always. Other than that, it's exactly the same structure. We just get all of the embeddings in bulk and then say, now I got a bunch of numbers, clustering model, please fit that. And then calculate the distance between everything and give me the result. So we'll define this function and then start by taking this file name, reading it as a CSV, and taking the specific column that we want, the text column, which was catchphrase, and getting the underlying clusters by grouping them. Let's see what the data set now looks like. So what it's saying is Beetlejuice, the first quote, Beetlejuice, 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 belongs to cluster 11. Its showtime belongs to cluster 8, which is the same cluster as the poltergeists. They're here. Again, cluster 8. Anything else in cluster 8? No. Hasta la vista, baby, and in case I don't see you, good afternoon, good evening, and good night from the Truman Show, both of those also belong to cluster 22, which kind of makes sense. Yeah, they're both greetings, right? Both of them are saying bye. So it kind of guesses the semantic meaning behind these and starts grouping them together, which is good. Now, I want to take all of these into chunks and give them names. So let's do that. What we're doing here is taking all of those, grouping those clusters, and then sending a prompt to GPT-4o Mini saying, here are 25 clusters of documents. Now suggest 2 to 4 word topic names for these clusters and give it to me as a JSON array with exactly the same length, which is 25 characters. Now, here is all my text. Take it, dump it, let it figure it out. And it's figuring it out. I may have already figured it out. And oh no, now is when it's figuring it out. This part can take a little bit of time. And let's see what topics it has identified. There's anger and revenge, confrontation and truth, money and greed, casual humor. This is the style of quotes. I could have obviously changed the prompt and picked any other style of quotes that I want. Now let's take these 25 and group them into a higher level. Cluster these topics into, n topics in this case happens to be 5. Cluster these topics into 5 groups and return a JSON with a 2 to 4 word description at a higher level. And let's see what that gives us. So we are effectively creating a topic hierarchy dynamically. Note that I wasn't changing anything in the notebook. I'm just running it flat. So this is a public notebook that you'll be able to take and replicate. The link is on the GitHub repo. And it says emotions and conflicts is one major topic. Humor and entertainment is another. Adventure and fantasy is another. Reflection and wisdom is another. Turns out that there are only 4 categories. Okay, fine. So what are in some of these categories? Let's take anger and revenge. Yeah, 0. So what is in anger and revenge? A Time to Kill. Yes, they deserve to die. Network. I'm as mad as hell. Planet of the Apes. Braveheart. Yep, all of these are the anger and revenge theme. So mostly using embeddings and with just generations for naming, we are able to group them, identify what those topics are, and then we can save it into Excel. Of course, the whole thing can be automated in a cleaner way, which ChatGPT has told me to do by using one of the tools that we were playing around with. What I'm going to do is take this tool that we built that does exactly the same thing that that notebook does, but using a GUI. So I pasted it and said my header is in the first row. Just cluster the stuff. So it's clustered it, and these are the documents. Now I can control the similarity of these by saying, okay, show me everything that's got at least some similarity. At some level, everything is similar. And show me the stuff that's connected only if it's really, really similar. So what is the single quote or the single pair of quotes that are very, very similar? They're here and they're back. Yeah, okay, makes sense. Those are really similar. What about, oh, okay, now it turns out that there are, okay, there's at least one more distinct cluster. And this is, it's showtime and it's clobbering time. Yeah, again, makes sense. These are similar. What is this cluster? It's something that's similar to something that's similar to something. Okay, so I'm guessing here, let's take the bottom 2. Oh, okay, I shouldn't have done that. Let's take, okay, what is this? This is there, here, and there, back. And this is, okay, here's Johnny and it's over Johnny. They happen to be connected because here's Johnny and they're here are both very similar. And we can keep going down this to see which are those similar cluster dialogues, but also interestingly, we can get to see what are the outliers. What is that one dialogue that seems to be very different? Mash it, don't text. Okay. Anything else that's slightly different? Turns out that there's one that's popped out here. There can be only one. Yep, that again doesn't seem to fit as well as the rest of it. So this gives us another way of exploring text that we otherwise wouldn't have really thought of, which is what's very different and what's very similar. We can, of course, follow the same process as before, which is give me maybe 10 topics this time, name them using Llama 3B, and blah, blah, blah. using a similar prompt. So cluster and then find the topics. So it's clustered them, it's identified the topics as, okay, there's one about movie quotes, iconic movie lines, infamous movie quotes, blah, blah, blah. And then I could take this and figure out what groups they belong to. So, cool. Given something like this, can I apply it to the actor network? Before I go there, okay, ChatGPT didn't quite remind me about this, but anyone has any questions at any point, please just speak out. You don't even need the mic, I can probably hear you. Next. Okay, so now let's get into image embeddings. It turns out that images can be embedded just like text. And the best part of it is that these images can be embedded in roughly the same space as the text itself. Now, what that allows is for us to take an image, understand what concepts it represents, without using any generation tokens. And as you remember, that is crazily cheap, which means that I could take 1,000,000 images, probably, and run it for $1 or $2, and find out which images are similar, which images are very different, which images are very close to some specific piece of text. Let's see how this works behind the scenes. One of the models that allows us to do this is Google's multimodal embeddings API. There aren't that many popular multimodal embedding models, by the way, which is a pity, but here's one that seems to work pretty well. And the way it works, I wonder if there's an example here that ChatGPT provides me with. Hey, this is not my talk. Did I just completely lose my session? Wow, I seem to have lost some of the chats. Okay, I'm at the part where I'm talking about image embeddings. Help me with what to say. I completely forgot. Yeah, okay, we're talking about all of this stuff. Great. And it does give me an example. So the way you would use this is you would send a HTTP request where you take the image base encoded and let it know that it's image/JPEG or PNG or whatever format you have. And you can also put in a piece of text, such as smiling person. What it will do is give you the embeddings for both the text and for the image. Incidentally, you can also send video, but I haven't really tried that. And specify how many parameters you want. That's basically the number of numbers that you want. I don't know how much you can control that. But if we use this, okay, this is not the visual aid that I want. For image, okay, for image embeddings, what link should I show? Yeah, that's fine. What about the actor network? It may have, okay, it hasn't lost the plot. Fine, cool. So let's now start applying it to the actor network itself. What we will get to is a bunch of actors like this using the same API, and I'll show you how it can be done live. First, let me show you how it can be done live. If I have a bunch of images, let's pick a few images of Arjun Rampal, a few of Arshad Warsi, and a few of Asin. So these are the 6 files that I have. Let's start by looking at male, who are female. What else? Any suggestions on what I might want to categorize Arshad Warsi, Asin, and whoever else as, Arjun Kapoor as? Bearded. Oh, okay, yeah, good point. Yeah, okay, bearded. Fine. Let's try with these. So, oh, sorry, I missed this. Let's try that again. 6 people. And yeah, it's going to take time. By the way, one of the tricks I generally use is when it comes to progress bars like these, I fake progress bars. This is not the actual amount of time that it's going to take. It's just happily guessing how much time it will take and showing a number, pretending that it's working. But in this case, it actually worked. And it says, okay, Y-axis is female, X-axis is male. So Asin is clearly high on female and low on male, whereas Arshad Varsi and Arjun Rampal are the opposite, which is good. Which of them are bearded on the X-axis? Asin is clearly not. And yeah, Arshad Varsi in this picture is, Arjun Rampal in this picture kind of is, so is Arshad Varsi. And yeah, so now we've built an image classifier at ultra low cost using LLMs, but without the prohibitive cost of LLMs, which can also help us kind of quantitatively say, look, these three are about as bearded, and these two are similarly unbearded, but the most unbearded is this picture of Asin. Or pick any other characteristic that you want, long hair, and not that we can see much of the hair, but let's say lots of hair, and see how that plays out for this. In this case, it should not take that long because all of this stuff should have been cached, but heaven knows, maybe it's just doing all of this again. And if I take now lots of hair, this picture of Asin, it says has a lot more hair, and it thinks, oh, sorry, lot less hair. X-axis is lots of hair. Oh, okay, fine. It's clearly got this wrong. So it thinks that Arjun Rampal in this picture has more hair than Asin in this picture. And this is one of the problems with embeddings. You're not really sure what it's correlating, how exactly it's working. There's less reasoning about it. So a lot more trial and error is required in such scenarios. But we will end up having to do a few iterations because it's such low cost. We don't even have to do the iterations. We will tell the LLM generate 100 things that I can possibly think of. It will generate the embeddings. We will apply the clustering and see the result. So let's dive into the actual results. First, I tried this with the most popular Hollywood actors. So there's Clint Eastwood, there's the Spider-Man guy, Tom Holland, there's, who's this? Meg Foster, I'm not sure who that is. Let's ask the question, which of them are smiling and which of them are frowning on the y-axis? Actually, no, let's start with something else. Let's start with the question, which of them are African on the x-axis? Morgan Freeman, clearly the most African of the lot. And that is Yu Jung, who's the least African of the lot. And we have Clint Eastwood kind of closer to the less African. Yeah, clearly there are 4 Africans out here. And you can see that split. You can see that divide forming. Though I don't know what I would call this particular divide. Anti-African? Maybe. And Chinese, yeah, okay. Jackie Chan just stands out there. And a group of people who are very clearly Chinese. And it's interesting that it thinks Catherine Winnick is borderline Chinese, but that's kind of where it might draw the cut. And Zendaya is probably the least Chinese of the lot. Feminine, okay, so Clint Eastwood is on the left side, good. We have Anne Hathaway as closest to feminine. Who is this? Elliot Page is right in the middle of a bunch of lovely ladies. Okay, interesting for him. And yeah, okay, Johnny Depp is kind of borderline. Ooh, that is Kevin Hart. That was surprising. And Meg Foster is a little bit on the left. We have Jennifer Morrison a little bit on the left. You've got to take all of this with a pinch of salt. It gives you a first cut. But for it to be really used in a production system, you'll have to build layers on top of it. This is a reasonably low-level infrastructure setup. So let's now move on to the Bollywood actors and answer the question. Which of these are actors and actresses? So what it's saying is the y-axis is actress. So clearly all the actresses are on top. The most actressy of them is Bhumi Pednekar. And the least actressy among the actresses seems to be this picture of Aishwarya Rai. No idea why. But you don't need to think twice, and these are obviously the actresses and these are obviously the actors. So with 2 of these parameters, we are able to figure out that divide very clearly. Okay, which of these are happy? Okay, Hrithik Roshan is like really happy. And this is a picture of Huma Qureshi, who's the least happy. But this picture of Pooja Hegde kind of looks happy. I'm not sure why it thinks maybe it's a relative scale. But it's also interesting that they think, that is an interesting slip. I said she thinks and started thinking of models as humans. But Amitabh Bachchan, who is clearly not very happy in this picture, seems to be happier according to the model than Pooja Hegde. And you'll see a lot of women on the left side indicating that the standard for women being happy in pictures of actors is probably higher. You'll see mostly actors on the right side. Okay, Anushka Sharma with a big grin is there on the right side, but it's a large number of men who are moderately smiling. And you can see that most of the women are at least mildly smiling in any case. Who does it think is the least North Indian? Tushar Kapoor. Okay, it's fine. But let's go to the main question that we were looking at, which is who's similar, who's dissimilar. Let's start by looking at who are the most similar actors. And I can start moving the slider. This is where I can get to see the biggest lookalikes. And it's saying this picture of Ritesh Deshmukh and this picture of Ritesh Deshmukh, yeah, they're very similar, but Shreyas Talpade looks very, very similar to both of them. Okay, Ritesh Deshmukh and Shreyas Talpade, I don't know if they acted together in the movie, but okay, and the first hit here is, am I the only one who used to think that they were brothers? Okay, so some validation there. They do seem to look alike. Pictures, yeah, kind of vaguely similar, but at least in this set of pictures, they are the most similar set of actors. Who else can we add to this list? Let's keep moving. So it turns out that this picture of Rajkumar Rao is reasonably close to Ritesh Deshmukh. So Ritesh Deshmukh seems to have a kind of central anchoring face that is not very different from many of the other actors in Bollywood. So you can probably replace many actors with Ritesh Deshmukh. The others that come in, okay, Shah Rukh Khan looks like Shah Rukh Khan. Yeah, fine. And Varun Dhawan looks like Varun Dhawan, Aishwarya Rai looks like Aishwarya Rai. All of these are validated. Let's look at the outliers. Who looks different? And let's start finding some of the outliers. So the actors with faces that seem to be the most different, the single most different face in this set of Bollywood actors is Tushar Kapoor. Completely distinct. And we then have who else coming in? Okay, Manoj Bajpayee seems to be quite different, and that is Kunal Khemu. Again, these are actors who are slightly outside. You're going to have trouble finding other actors who look like them. Now, I promised that we'd get to Priyanka Chopra. Actually, I didn't promise, you asked. So let's see if we can find Priyanka Chopra somewhere and try our luck. I should have built this interface so that we could have searched for a character. But if anyone spots Priyanka Chopra on the left, please let me know immediately. Okay, if she hasn't appeared, then it means she's reasonably similar to the mainstream actors. This is going to take some time, so you might want to ready your questions by then, because we are going to wrap up in a minute or so once we spot Priyanka. And whoever has the mic.
Sure. Requesting anybody who's questioning can go to the mic and ask the question, because we're all being recorded, so that'll be nice. So any questions, please raise your hand and you could go to the mic. Yes, sir, you can stand up. The mic is right in front of you. Thank you.
See Priyanka Chopra. Sorry, who was the question? Fifth row. Okay. Oh, in the fifth row. Oh, okay, great. Thank you. Oh, yeah, there she is. Okay, so Priyanka Chopra is similar to Priyanka Chopra. And who else is she similar to? Okay, Deepika Padukone is the closest in terms of similarity that we have to Priyanka Chopra. Finally, after 1 year, I was able to answer a fairly basic question at relatively low cost, at reasonable quality or accuracy. So what would I like people to take away? See, personally, like I said earlier, embeddings are the most underused capability that we have with LLMs. They're extremely powerful, they're very versatile, reasonably high quality because you can quantify them, they're extremely cheap. You've also seen that the kinds of uses that we can put them to is pretty versatile. Simply because they're quantitative, you can use them as the building blocks for many things. There's a bunch of tooling around it that you can use to support. So if there's one takeaway that I have for you, it is please explore embeddings, not just text, but multimodal embeddings. And I suspect you'll find stuff that's a whole lot more powerful. Thank you.